You probably use aspirin almost every week, but do you know how it works? Aspirin is one of the most widely used medications globally, recognized for its effectiveness in treating pain, inflammation, and fever. But how did this over-the-counter drug become such an essential part of modern medicine? In this video, we'll explore the chemistry behind aspirin, its discovery, and what makes it so effective in treating a variety of health conditions. The story of aspirin begins with the discovery of salicylic acid, a compound found naturally in willow tree bark. For centuries, various cultures around the world used willow bark as a remedy for pain and fever. The active ingredient in the bark is salicin, which the body converts into salicylic acid after ingestion. Salicylic acid is an effective anti-inflammatory, but it also has harsh effects on the stomach lining, which limits its use in large doses. Despite the healing properties of willow bark, early attempts to use salicylic acid directly for medicinal purposes resulted in stomach irritation, making it uncomfortable for long-term use. This prompted researchers to find a way to make salicylic acid more effective and less irritating to the digestive system. In 1897, a German chemist named Felix Hoffmann, working for Bayer, successfully synthesized a modified version of salicylic acid by adding an acetyl group to the molecule. This created acetyl salicylic acid, which we now know as aspirin. The addition of the acetyl group made the compound more stable and less irritating to the stomach, while preserving the same pain-relieving and anti-inflammatory properties of salicylic acid. This discovery revolutionized pain management. Unlike its precursor, acetyl salicylic acid did not cause the same level of stomach irritation, making it safer for broader use. Bayer quickly marketed aspirin, and it became the world's most popular painkiller, available to the public in a range of formats, from tablets to powders. So, how exactly does aspirin work on the molecular level? Aspirin's primary mechanism of action is through its effect on an enzyme called cyclooxygenase, COX. There are two types of enzymes, COX-1 and COX-2. These enzymes play a key role in the production of prostaglandins, which are lipid compounds that promote inflammation, pain, and fever as part of the body's immune response. When you take aspirin, it inhibits both COX-1 and COX-2 enzymes, which in turn blocks the production of prostaglandins. By reducing the amount of prostaglandins in the body, aspirin effectively reduces inflammation, alleviates pain, and lowers fever. This is why aspirin is so effective in treating conditions like headaches, arthritis, and even cardiovascular diseases. Aspirin is also used to prevent blood clots, making it an essential component of cardiovascular health. When aspirin inhibits COX-1, it prevents platelets in the blood from aggregating, reducing the risk of clot formation. This is especially important for people at risk of heart attacks or strokes, as it helps keep blood flowing smoothly through the arteries. Aspirin's ability to prevent clotting and reduce inflammation has made it a staple in treating cardiovascular diseases. While aspirin is highly effective, it is not without risks. Long-term use of aspirin, especially in high doses, can lead to gastrointestinal problems, such as ulcers or stomach bleeding, due to the inhibition of COX-1. COX-1 plays a role in protecting the stomach lining by promoting the production of protective mucus. When COX-1 is inhibited, the stomach becomes more vulnerable to acid damage. Because of these risks, it's important to use aspirin as directed and consult with a healthcare provider before starting regular use. Aspirin's role in modern medicine cannot be overstated. From its origins in nature to its development as a safe, effective medication, aspirin has revolutionized the way we treat pain and inflammation. Whether you're taking it for a headache or as a preventive measure for heart disease, Aspirin remains one of the most versatile and valuable drugs in the world. Understanding its chemistry helps us appreciate just how powerful this simple compound can be in improving health and well-being. As always, thank you for watching. If you have any video ideas, comment them below, and we'll see you in the next video.